Hello there guys, and welcome back to another epic Inexorable maths video. In this video we're taking a second look at sketching cubics, and we will remind ourselves that a cubic is some function in the form y equals ax cubed plus bx squared plus cx plus d, where a, b, c and d are constants that you will normally be given in the question. Okay? But that's the general form of it. So it looks a lot like a quadratic, but it's actually got an x cubed term in it as well. And a cannot be 0, but any of the others can. B, c and d are allowed to be 0. So we've got some crazy stuff on the board. I took way too long to draw all of this, but I hope it's worth it. Maybe drop a like, subscribe, you know, to appreciate such things. Let's break this down, because just like with quadratics, if we have things like double roots, we will get skims, we will go straight through the x-axis. It depends on what the function is, but nicely for any polynomial, quadratics, cubics, quartics, quintics, etc., there's normally rules. So this applies for all things. If you have some factor, x minus a, the point a will essentially be a root of the function, okay? So x minus, the minus is really important, okay? So for instance, if we had some function, let's actually look at this one for a second. We won't do this just yet, but let's use it as an example. So I know that the light is not too nice on this part of the board. This says, just for total clarity, y equals x plus 1, in brackets, squared, multiplied by x minus 1. That's also in brackets, okay? So, as an example, let's look at this one here, x minus 1. If we say that a is 1, then we have x minus a, right? So this would mean there is definitely going to be an intersection. If we were to draw this graph, which we will in a second, there is definitely going to be an intersection at the point 1, not minus 1, 1. And you'll see why in a second. It makes a lot of sense. But so we have x minus a. If we assume that a here, here and here is just some arbitrary number, it doesn't matter what it is, it could be positive or negative, it doesn't matter. If we assume a is an arbitrary number, I could have drawn it over here, I could have drawn it over here, it doesn't really matter, just a general point a, then if x minus a is a factor of ax cubed plus bx squared plus cx plus d, then it will go through the x-axis at the point a. So if x minus 1 was a factor, it will go through the x-axis at 1. If x plus 5 was a factor, it will go through the x-axis at minus 5, okay? If you have two lots of the same factor, x minus a squared, so we've got an x plus 1 squared, that's fine, okay? That is a double root. What this will do is it will skim the x-axis, but not actually go all the way through it. It will touch it, it will come up, it will skim it, and it will turn around. So this one was coming down, it's turning around, it's coming back up again. It's not going to go through. And you might actually recognize this pattern from quadratics when we talked about things like the discriminant. If there's one root, it does something, a quadratic does something very similar to this. It just skims it. So there's an overlap there. Finally, if we have a triple root, which is some x minus a cubed, then we have this monstrosity, which is essentially, when we are coming either up or down, these are all positive a coefficient cubics, by the way. These all could be starting down. So for example, you could have a double root that comes up, skims, and then comes back down again. But these are just examples. In this one, it comes up, again, could come down, but in this one it's going to come up. It's going to come from one direction. It's going to skim the x-axis, and then it's going to continue going through it. But it will not just go cleanly through like this. It will do this very strange shape here. Note that it's still only touching the x-axis once. If you had a magnifying glass and you zoomed in and in and in and in, it would just be touching once. But it's just clearly very close to the x-axis here and here, okay? but it zooms up. And again, if this was a negative one, it would come down, skim, and then come down again, okay? So, for instance, this literally the basic cubic, y equals x cubed, looks like, you guys should know this from GCSE, y equals x cubed looks like this, if I can draw, which as we should know by now, I can't. So this is the graph of y equals x cubed. But hold on, we can write x as x minus 0, can't we? So this is y equals x minus 0 cubed, because x minus 0 is the same thing as x. Okay, so that means that we can say that 0 is kind of like a in this, if we come over here. So yeah, if a is 0, which it is here, there is a triple root right here. It does this weird thing where it sort of touches it and then skims and then comes back up again, okay? So that's sort of proof that this is definitely the case, okay? But obviously if a was a different number, we would be in a different place. We might be to the left or to the right, and it might be coming downwards, okay? And just to be really clear, guys, this a is not the same thing as this one, okay? They're just letters, okay? So a is used here quite frequently, and it's used up here. This a has got nothing to do with this one. They're not related, okay? A is just a general solution, okay? So maybe in future videos I'll use a different letter instead of a, because I do see how that could be a bit confusing. Maybe I'll use like a p or something like that. Okay, so let's sketch y equals x plus 1 squared times x minus 1. Here is the x-axis, here is the y-axis. This is 0. Okay, so let's have a look at this. First of all, how do we solve this, guys? How do we figure out what the intercepts are? Let's do the x-axis first. How do we do it, guys? We do the same thing as always. We want when y is 0. Why? Because when y is 0, we are on the x-axis, okay? So we're going to set y equal to 0. We're going to say 0 equals x plus 1 squared times x minus 1, okay? These are being multiplied. We, if we want to, can rewrite x plus 1 squared as x plus 1 times x plus 1. So we can also say that 0 is equal to x plus 1 times x plus 1 times x minus 1, because x plus 1 squared is x plus 1 times x plus 1. That's what x plus 1 squared means. Okay, so we have this equation. Now all we need to do is solve this equation. How do we solve this, guys? We simply observe the numbers that you would need to put in for the x's to make at least one of the brackets turn into a 0. So literally, you can do this one by looking at it. Well, hold on. If this x here, if this was a minus 1, this would be minus 1 plus 1, which is 0. Which means just by observation, x must be equal to minus 1. That must be one of our answers. But this bracket and this bracket are the same, which means we're also going to get x equals minus 1 out of this. And finally, for this one, we would need to use a positive one, because 1 minus 1 is also 0. So another one is x equals positive 1. Okay? So we can say that, let's say this is 1 and this is negative 1. The graph is going to go through like this, okay? Now, a is positive, which means the graph is going to start by coming up, okay? So it's going to be coming up like this, right? Now, notice, just like how I've written here, this x plus 1 squared is in the same format as x minus a squared. It's just some constant. So, x plus 1, remember, it's in the form x minus a, which means that a must be negative 1, because we're doing x plus negative 1, or x minus negative 1, I should say. So, just to be really clear, x plus 1 is the same thing as x minus negative 1, right? X minus minus 1 is x plus 1, which means this is now in the form x minus a, as we can see here, where a is negative 1. So the negative 1 is a double root. The double root is this one. Okay, so let's now observe. It's a double root. If we come from below and we get a double root, the only possible thing that can happen is we come up like this, we skim, and we have to come back down because it's a double root. So we come back down, okay? And now, the last thing we need to do is we need to simply figure out what the y-intercept is. It's probably going to be negative, just by looking. And then, wherever that y-intercept is, we need to connect it back to this guy here. So, let's look at the y-intercept. What's the method, guys? You can, if you want to, expand all of this out using FOIL, or you can look at the constants and multiply those constants together, as we already mentioned in the last video. So we do 1 times negative 1. 1 times 1 is 1. 1 times negative 1 is negative 1, which means the y-intercept is negative 1. So we're going to be about here. We're going to say this is negative 1. We come down, and then we're going to come back up again, because a cubic has to do that, basically. Okay, a cubic must do this shape. Okay, it's important to know every single cubic always starts going in one direction. So this one starts coming up and ends coming up, or it starts coming down and ends coming down. Okay, so they all start off, and you can see it here: up, 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 up. They all do it. So this is the point negative 1. This is the point 1. This is the point negative 1, or I should say, I guess you could say this is 0, negative 1. This is negative 1, 0. This is 1, 0. Okay, just like that. Nice. So these are the coordinates, and if we want to, we can label this y equals. I don't know why I'm going vertically. If you want to do it horizontally, you can. But this is the double root scenario. Okay, guys, let's take a look at a triple root scenario this time. You'll actually find the triple roots are not as difficult because, guys, the triple roots, there's just going to be one intersection on the y-axis all the time. So again, guys, same method. Let's label this x and y actually. Guys, we want the x-intercepts, okay? That's all we need. So let's just have a look. So let's say 0, because guys, once again, when y is 0, we're on the x-axis, that's what we want. We want to know when we're on the x-axis. 0 equals x minus 1 cubed. If we want, we can rewrite this as x minus 1 multiplied by x minus 1 multiplied by x minus 1. So we've got 3 lots all multiplying together. That means x minus 1 cubed. And just by looking at it, guys, there is one value for x which is going to help us here. Which value for x makes all of these, guys, all of these brackets turn into a 0? If x was 1, 1 minus 1, 0. Doesn't even matter the rest. It's going to turn it all into a 0. These are all identical brackets, which means obviously, and you can actually tell just from this guy here, that of course the answer is x equals 1. Which means, guys, if we say that this is x equals 1, roughly here, that is all we're looking at. Once again, a is positive, and when I say a, I mean this guy here. The leading term, the x cubed coefficient, is an a, which means we are going to be coming up and finishing coming up, or I should do it this way. We're going to be coming like this. So guys, we're going to be coming roughly like this, skimming, and then shooting back up again, okay? And now we want, what is this y-intercept? What are we looking at here? Okay, well, all we do is we multiply minus 1 times minus 1 times minus 1, the coefficients. Because the reason why we multiply the coefficients to find the y-intercept is because if you expanded this out, I guarantee you'll find that the constant, which is d, is always going to be just this term times this term times this term. Minus 1 times minus 1 is positive 1, Positive 1 times minus 1 is minus 1, which means this point here is minus 1. So we can say that the actual point is going to be 0, minus 1. This point here, this is 1 on the x-axis, where we can say this is 1, 0. Once again, this is labelled y equals x minus 1 cubed, just like that. And that is what the graph looks like, guys. So it's actually just a sort of translation of the normal graph y equals x cubed, but it's moved to the right by 1 unit, okay? So that's all there is to it. One final thing I will say about this topic is if you ever get a y equals and it's not factorized, so it's literally just, it looks more like this, either if it's in sort of, if you're this early on in the A level, you will be able to factor it because you can just take an x or some multiple of x out of it, okay? So for instance, if you got something like y equals x cubed, let's say, I don't know, minus 2x squared minus x, something like this, right? I'm totally making it up. You could then say, okay, y equals x times x squared minus 2x minus 1. And then you could factorize that, okay? So, and then you would figure out what's going on there, okay? So that's just an example. So then obviously this is when x, this would go through the origin, x is 0, we're on the x-axis, and then this would be whatever that is factorized. So you can get this. If you get it later in your A level, fear not, because we will soon learn how to factorize things that look more like this. We'll learn how to actually factorize them, okay? Anyways, guys, I know it's been a long video. Thank you so much for watching. Please like, subscribe if you enjoyed this video. Share with your friends and family. You know, Christmas is coming soon, guys. I know we're only 6 months away, or a year and 6 months. Who knows? Thank you guys so much for watching, and I'll see you in the next video.